So here's another question dealing with experimental data, and from this data we're going to be able to determine a rate law using the initial rates method. So we're looking at ClO2 reacting with hydroxide ion, and we don't have to worry about the products. So given this following experimental data, determine the rate law for this reaction, determine the reaction order with respect to both reactants, and determine the overall reaction order. So that is the question. And as we did in the past example, we're going to compare experiments to see how changing an initial concentration of a reactant affects the rate of that reaction. So if we look at experiments 1 and 2 here, 1 and 2, we can see that the concentration of ClO2 is held constant and the concentration of hydroxide ion is doubled. So this, comparing experiments 1 and 2, is going to determine an effect on hydroxide ion concentration change on rate. So that's going to be useful. And if we look at experiments 1 and 3, we can see that the hydroxide ion concentration is held constant, 0.025 in both cases, whereas the ClO2 ion concentration is changed. So those are the two reactions we're going to compare. So let's look at reactions 1 and 2 first. And so what we're looking at here is an effect of rate by changing the concentration of hydroxide ion and how that's going to affect rate and allow us to determine the exponent for that reaction. So if we look at what has happened to rate, first of all, rate goes from 1.30 times 10 to the minus 3 to 2.6. That's a doubling of rate. So rate has gone up by a factor of 2. Well, that's proportional to a concentration change. Well, what do we do to the concentration of hydroxide? We doubled it. So it went up by a factor of 2. And that leaves us with the exponent x. And so by just by looking at it, you can tell that x equals 1. And so this reaction is first order in hydroxide ion concentration. Okay, so that's experiments 1 and 2. Now we can go and look at experiments 1 and 3 to look at the change in or the effect of rate by changing the concentration of ClO2. So again, what we're looking at here is a rate effect caused by ClO2 concentration raised to some exponent. And so in experiment 1, if you look at rate first, it went from 1.3 times 10 to the minus 2 to 1.16 times 10 to the minus 3. Well, how do you do the math on that one? Well, simply 1.16 times 10 to the minus 2 divided by 1.30 times 10 to the minus 3 should give you some number. And what's that number? Well, that number, when you do the math on, was 8.923, which we can round to 9. So that's to say that the rate has increased by factor 9. Well, what do we do to concentration? Well, 0.015 increased to 0.5045. We tripled the concentration raised to that exponent y. And again, by inspection, y must equal 2. 3 squared equals 9. So there we go. And so that is to say that this reaction is second order in ClO2. And so now we have the tools, all the information you need to write a rate law. R equals K, ClO2 raised to the exponent 2, second order, OH minus 1, first order, and overall reaction order is 3, or third order. And that concludes this video.